Hello students, I welcome you all in the 11th lecture of the TOC. In last class we have seen that some context free languages are given and we have designed push down automata for that particular context free languages. So today also we will first of all see the yesterday's two examples which I have given to you for as a homework, and I hope you have gone through that. And first of all we will particularly solve that example p raised to power n q raised to power 2n plus 1. Already we have seen example like this, that is p raised to power n q raised to power 2n. Only difference is that here we have extra q. Okay, so how to tackle with that extra q we are going to see now. Okay, and after completion of these two examples we will see another type of examples, and for that we are going to use non-deterministic push down automata, and also we will discuss what is difference between push down automata, that is this deterministic push down automata and non-deterministic push down automata. Also we will see whether the deterministic push down automata accept which type of languages and non-deterministic push down automata accept which type of languages, whether that be equal or non-deterministic PDA is accepting more number of languages. That we will see in this particular lecture. Okay, so let's start with the previous example. So this is the example. We have to design a PDA for the language L is equal to p raised to power n q raised to 2 power n plus 1, where n is greater than or equal to 1. So if we will write some strings present in this particular language, then minimum length string becomes this p when n is equal to 1, and this qq when n is equal to 1, this q raised to power 2n, that is qq plus 1 extra q. Okay, then next language will be when n is equal to 2, then it will become pp, then 4 times q, because 2 times p becomes 4 times q, and this extra q for this plus 1. Okay, this is one of the string. Also if you will write, then another string will become, this is q 6 times q and that extra q. Okay, so the language contain infinite number of strings. Okay, so we have already solved example or we have already designed a PDA for p raised to power n q raised to power 2n. So for this example what we need to do, whenever p occurs we have to push that p into the stack, and whenever q occurs we have to pop that particular p with respect to, whenever q occurs we have to pop p. Okay, and this example we have solved in two ways. Okay, so here just a second. Okay, so we have seen that for this example we have solved in another approach, that whenever p comes we will push that p into the stack. Suppose this is the stack and bottom of the stack is z0, and I will take this string, okay, this string as an input. Whenever p comes I will push that p into the stack. Whenever next p comes I will push that particular p into the stack, and whenever q started occurring, for first q I will just read that q. I will just read that q. I will not do any operation on the stack. Whenever I came across the second q, what I will do, I will pop the one p for particular that q. So I have popped that p and I have moved my top pointer here. Okay, so again I came across third q. Whenever odd number of q's are coming we have to read that, and whenever even number of q's are coming we have to pop that. Okay, pop that particular p with respect to that q. So This is the first time Q occurred and this is the second time Q occurred. Whenever third time occur, I will move backward. When Q occurred and top of the stack is P, I will put that as it is P and I will move to the backward state. Okay. Again, whenever 4 times Q will occur and top of the stack is P, again what I will do? I will pop particular P for that Q. Okay. So I have popped this particular Q. For this Q, I have popped this P and I have moved my top pointer here. Now I am left with Z0 and top of the pointer, input is Q. Whenever I have left with Z0 in the stack and remaining is only Q as input, then I can understand that this Q because of this +1. So for this, I will not go to the directly to the final state. For this transition, what I will do, when I am with Q as input and top of the stack is Z0, I will make that as Z0 only and I will move to the next state, that is Q3. And finally at Q3, what I will do, I am left with input as epsilon and top of the stack is Z0, then I will put that Z0 as it is and I will move to the final state, that is QF. Okay, so this is the PDA for particular this language. Okay, let's see the another one. So this is the example. In this example, if we will carefully observe that here this P will be matched with only this R because P and R are having same power, and Q will be matched with S. But when P occurs, if we will push these P into the stack, then we cannot directly come across R, because if we will write strings present in the language, then strings become, suppose n is equal to 1 and m is equal to also 1, then minimum length string is PQRS. Then n is equal to 2 and m is equal to 1 only, then Q R R S. Suppose P n is equal to 3, then this 3P and m is equal to 2, then QQ triple R double S. We will get infinite number of such strings present in the language. But whenever we will come across in designing the PDA, we have stack and top of the stack is Z0. If we will push P into the stack and we came across the Q, okay, so suppose we have pushed Q also into the stack, then top of the stack becomes Q and input is R. So we cannot pop P with respect to R because top of the stack is Q and input is R. So we will not able to match this R with this Q. Okay, so this example, we can say that this example cannot be a regular language, a context free language, and it is not a context free language. That's why we are not able to design a PDA for this particular language. So designing PDA for this language is not possible. Okay. In this example, we have to design a PDA for the language. Language is given W reversal, where W belongs to the A comma B. Okay, means whatever number of strings possible, that is of A comma B only. Okay, and A comma B closure is there, so that A comma B will not be epsilon, means minimum one length should be there. W is one length string, always be there. So example, suppose W is, we will take W is, suppose A B B, then W reversal will be B B A. So if we will write strings present in the language, then minimum length string will be A, because A, suppose A is the, then B B, then suppose A B B, then this will become B B A. epsilon will not be there because here plus is there. Minimum one length string should be there. So one length. So W reversal is also one length. Okay. Then AA is W. Then W reversal will be double A. Similarly, AB, BA, like this. We will get infinite number of palindrome strings. And in previous example, WCW reversal was there, and for identifying the middle of the string we have one symbol is there, that is C, that is different from this A comma B. But in this situation we don't have any symbol to recognize whether the center has came or not, means whether W is over or not. We have to assume that. Okay, so let's see how to assume that. And by using this string we will get even number of palindrome strings. In previously we are getting odd number of palindrome strings. By using this we will get always even number of palindrome strings. Okay, so basically we don't know the center, exactly where is the center we don't know, because in this example we are not given with one extra symbol. So in this example we have to assume that. Whenever we have to assume that, we have to assume two solutions. So first solution we can say that okay, we will assume that the center has came, means W is over, and another way we have to assume that W is not over yet. Okay, means we have two solutions, we have to assume two paths. So whenever we are with two paths, more than one path, means that is not a deterministic. Whenever deterministic is there, we are always following one path, but whenever non-deterministic is there, we can follow one or more paths. So for this we cannot able to derive the solution in deterministic way, we have to go with non-determinism. So here we will design non-deterministic PDA for this one. Okay, so let's start from Q naught. Okay, Q naught is a initial state, and initially suppose we have the string like ABB and BBA. Similarly I will write BAA, AAB. This is the reversal, finally epsilon, finally epsilon. Okay, so we will assume both the strings because we will get all the transitions. So initially if I will go with this string, so top of this input kya hai, A is the input, and if I will consider the stack contains Z naught. Okay, so A on Z naught, I have to push that A into the stack. Similarly, if I will go with this one, then initially if B occurs and top of the stack is Z naught, then for this B also I have to push. So B on Z naught, I will push B into the stack. Okay, now stack contains, suppose for this A and input is B. So input is B and stack contains A. These are different symbols. Actually problem occurs when same symbol is there, means top of the stack is same and input is also same. In that case we have to assume that whether center came or not came. But here we are with different symbol, B is the input and A is the top of the stack, so we can easily push. So B and top of the stack is A, then we will push that B into the stack. So this is become BA. Okay, and similarly for this string, this is the Z naught and initially B is there and next symbol is A. So whenever input is A and top of the stack is B, we can push because these are not same symbols. So A is the input and top of the stack is B, so this will become AB. Okay, so for this we are having this stack and for this string we have this stack. Now next is here top of here input is B and now we are with top of the stack is also B. So here we have to assume two ways. Suppose if I will assume, so if I will assume center is not came, means W string is not over, then I will push that alphabet into the stack. So B occurred and B is the top of the stack, so I will push that B into the stack when center is not came. Okay, but if center has came, then I have to change the state and I will write that transition. So transition becomes B as input and B is the top of the stack, then I have to pop. Similarly for A also, if I am assuming that the center has not came yet, so A is the input and top of the stack is A, then I will push that A into the stack. But at the same time, if I will assume that center has came, so input is A and top of the stack is A, then I have to pop and I will move to the Q1 state. Okay, now here what will be there? So for this is for one input, so ABB has already pushed, suppose understood ABB is already in the stack, so B and B is matched, so I have popped this B. Next again this B is there and again I have to match B, so B on B I have to pop. Similarly if I will pop this B, now I am left with A and top of the stack is also A, so A on A I have to pop. Okay, so finally I will get, suppose I will get epsilon in the string, input string, and top of the stack becomes Z0. I will make that Z0 as it is and I will move to the final state, that is QF. So this is the non-deterministic PDA for particular this language. Okay, now what we will do, we will take one string and we will trace that string and we will check whether we will get an or we can say that we will check whether we will end up with a final state or not. Okay, we will assume both the ways, center came, center not came. Okay, and after assuming all the solutions, at least we need one solution that is ending with final state, then only we can say that the particular string is accepted by particular PDA, that is non-deterministic PDA. So let's assume that string, suppose we will take string 4 times A and we will check that is accepted by this non-deterministic PDA or not. So let's assume the given input is 4 times A and we have to check whether that particular input is accepted by this non-deterministic PDA or not. Okay, so initially we will assume we will start from Q0 state and we will write the input here which is not yet processed. Okay, and finally we are with Z0, that is the top of the stack. Okay, so let's assume that first A occurred, so we will stay Q0 on input is A and top of the stack is Z0, so input is A and top of the stack is Z0, then what we have to do, we have to stay in that state only, Q0. Now remaining input is triple A, or we can add epsilon also here, so epsilon here, and finally we have to push that A into the stack. Now we have two options, we have to assume that whether center came, no center, or here we will assume that center. Okay, so whenever same input is there, means given input is A and top of the stack becomes A, then same alphabet is there, then we have to assume that whether center came or not came. So if we will observe center came, so A is the input and top of the stack is A, I have to pop, so Q naught. So I will go into the Q1 state and I will pop this A for this particular A. Sorry, I will pop this particular A for this given input A. So Q1 remaining input is AA. Here epsilon is there finally, and that is Z naught. But if we will observe this Q1 and Q1 पे क्या चाहिए हमें, A as the input है and top of the stack is Z naught. So A is the input and top of the stack is Z naught. There is no such transition available. So we cannot move further by using this way. So this in this way, if we will solve, we will end up with a dead configuration. So this is the dead configuration. Now let's say suppose no center came, so this will become, this is Q naught. We have to stay in Q naught only when A is the input and top of the stack is also A. We have to push that A into particular stack. So Q naught remaining input is AA, and we will push that particular A into the stack. So stack becomes AA Z naught. And finally here epsilon is there. If I will forget to write that epsilon, consider that epsilon there only. Okay. So here also, if I will assume that center came and here no center, so first of all, we know that we are going, if we will solve this way, we will get a center. So here I will assume that till center not came, so this is become Q naught, and this is A. A on A, I have to push that A into Z naught. Okay. So here also I will assume that center came, okay, and here no center. So if no center is there, means Q naught is there, and finally I am remaining with epsilon, and stack contains 4 times A Z naught. Here and in this way we will get Q1. Here I am getting epsilon, and top of the stack is AA Z naught. Okay. So suppose I am in Q1, epsilon is the input. What I need? Top of the stack Z naught, but I am getting top of the stack is A. So I am ending in a dead configuration. So this is not a possible solution. In this way also, suppose I am in Q naught and input is epsilon. So input is epsilon, there is no such transition available in the PDA. So here also we are ending in a dead configuration. So let's solve this one. Suppose I am considering center has been came. So this will become Q naught. Okay, center has came, so we are moving to the Q1. So let's write here Q1, and this for this particular A, this A is popped. So this will become Q1 A. Epsilon is the remaining input and remaining stack alphabets are A Z naught. Again in this way I am in Q1. Here we don't need to assume that center has came or not came, because we are in Q1, and Q1 on input A and top of the stack is A. We have only one transition, that is A on A we have to pop. So I will stay in particular state only Q1, and I am remaining with epsilon, that is the input, and top of the stack is Z naught. So again in Q1 I will check if input is epsilon and top of the stack is Z naught, what I have to do. So if input is epsilon and top of the stack is Z naught, I have to make that Z naught as it is as a top of the stack, and I will move to the final state. So here by this way I am moving in the QVF state, and that state is final. So at least one way I am ending in a I am reaching in a final state. So if we will get at least one reachable state, that is final state, one way final state, so we can say that this particular input is accepted by this particular NDFA. Okay, so let's take another one, so it will clear more. So this is the example. We have already gone through the example, like real language is given, so that is a raised to power n, b raised to power n when n is greater than or equal to 1, and also we have gone through the language a raised to power n, b raised to power 2n when n is greater than or equal to 1. But in this case, that is the union is present. So whenever a union of two language is there, that is not a deterministic context free language. So we are not able to design a PDA, that is deterministic PDA, for this one. So we will try designing a non-deterministic PDA for this one. So basically, if we will write the strings present in the language, the strings become, suppose from this I will get minimum length string as AB. Similarly, AA, BB. If I will try this one, so I will, when n is equal to 1, I will get A, BB, or AA 4 times B. Like these, we will get the strings present in the language. Okay, so we know the PDF for this one and PDF for this one. So first of all, what we will do, we will create, or we will design a PDF for that languages. So I am in Q1. For this, what I have did, I have pushed that A into the stack, and each A has been popped by using each B. Okay. Similarly, for this, I have pushed, for single A, I have pushed two A's. Okay, two A's for single occurrence of A, and similarly, whenever B started occurring, I have started popping that particular A. So first of all, I am in Q1, and whenever stack is empty, that is, it contains, top of the stack is Z0, and whenever A occurs, I will push that A into the stack. So this is become A Z0. And whenever stack contains A and input is also A, then I have to push that particular A into the stack. Now whenever B started occurring and top of the stack is A, I will start popping, and I am moving to the next state, that is Q2. Okay, here again, if I will get more number of B's as input and top of the stack becomes A, I am doing popping only. And finally, if I am left with epsilon and top of the stack is Z0, so I will make that Z0 as it is, and I will moving, that is Q3 state, and that Q3 state is final state. Okay, so this is the PDF for this particular language. Similar way, we will design PDF for that next language. Suppose I am in Q4 state. And if I will get single A and top of the stack is Z0, so I have to push two A's. So I have pushed that two A's, and when A is the top of the stack and A is the input symbol, I have to push two A's for this one occurrence of single A. And at other hand, when I came across with B as input and top of the stack is A, I am doing popping. So I have to do pop operation. So I am in Q5 state now, and here also, if I will get more number of B's as input and top of the stack is A, then also I have to do the pop operation. And finally, if I am left with epsilon and top of the stack is Z0, I have to make that Z0 as it is, and I am moving to the next state, that is the Q6 state. Okay, so this is the DFA, and Q6 is the final state. This is the PDA for this particular language. Okay, now but the entire language is a complete language, so we have to combine these two PDAs into one. Okay, suppose I will take a Q0 as a starting state. Okay, in this state, if I will go in this way, I will assume that I am getting the strings like these. Okay, whenever such type of strings I will end up with this PDA or this way, and whenever I will get these type of strings, I will end up with these ways, this way. Okay, so if I'm ending with this way, so initial transition becomes A is the input and Z naught is the top of the stack. So I have to make that A as the top of the stack, means I have to move that particular A into the stack. So here also I have the transition, that is A on Z naught. So I will cut this transition from here because already this is doing this particular transition. Okay, next time whenever I have to push that particular A, top of the stack becomes always A. Similarly, if I will follow this way, suppose for single A I have to push two A's, I will follow this way. So A is the input and top of the stack is Z naught. So I have to insert two A's for particular A, because I am assuming the given string A B is there, but here I am assuming that next first A is occurred, and I am assuming that the string becomes not AABB, the string is become AA 4 times B. I am assuming that. Okay, so that's why for single A I am putting 2A into the stack. Similarly, already this operation is here, so I will cut this operation from here, and finally I will follow this path if I have to accept such type of strings. So whenever the input is given and we are ending with one possible solution, then we can say that particular string is accepted by this non-deterministic PDA. If we are getting a string like AA triple B, so we are not ending with anywhere, so we can say that this particular string is not accepted by this NPDA. Okay, let's check for this string whether we are ending with a final configuration or not. Okay, so A is the input. Suppose I will follow this path, so I will insert single A into the stack. So I will directly insert single A, and this is Z naught. Okay, single A into the stack, and again for next A I have to insert. Okay, and now top of the stack is this, and input is B. So on B I have to pop 1A. For this B also I have to pop 1A, and now I am left with B, and I need a top of the stack is A, but top of the stack is now Z naught. So B on Z naught, there is no such transition is available. So I am not ending with a final state, I am ending with a dead configuration. For this similar way, if I will follow this way, so for single A I am pushing, okay, for single A, so this is Z naught, assume. For single occurrence of A I am pushing two A's. Okay, for this single A I have pushed two A's. Again for this single A, by using this transition I will push two A's. So I have pushed two A's, and now B is there. For this B I have popped this A, for this B I have popped this A, for this B I have popped this A. Now my top pointer becomes, top of the stack pointer becomes at A, top of the stack is A, and I need one B as an input, but I am ending with epsilon. So epsilon on A, there is no such transition is available. So again for this way also we are ending with a dead configuration for this particular string. So we can say that in either way we are not accepting this string. So we can say that this particular string is not accepted by this non-deterministic PDA. So we can say that particularly this string is not a part of the language. Okay, so let's see the another example. So this is the last example. For this example we will design a PDA. So example is like this. The language is given, the language is a raised to power I, b raised to power j, c raised to power k, d raised to power l, such that I is equal to क्या है, k है और j is equal to l है. दोनों में से एक चीज ट्रू है. okay, and when at the same time I is greater than or equal to 1 and j is greater than or equal to 1. So if you write some strings belonging to particular this language, the string becomes ABCD when I is equal to 1 and j is equal to 1 is there. Okay, when I is equal to 2 and j is equal to 1 is there, then I will get this string. Okay, and similarly when I is equal to 1 and j is equal to 2 is there, I will get this string. When I is equal to 3 and j is equal to 1 is there, I will get this string. Similarly I will get infinite number of strings. So either one of the way is true. So when I is equal to k is there, I is equal to k is there, I have to push. Okay, let's wait. So when I is equal to k is there, so in this situation whenever I is equal to k means whatever number of a's are there, exactly we will get that number of c's because I is equal to k is there. So if I will consider I is equal to 10, then k is also 10. So if I am getting 10 a's, then at the same time I am getting 10 c's. So for this the logic is like this: whenever a comes, we have to push that a into the stack. Okay, after that we will get b's, and that b should be at least 1 because j is greater than or equal to 1. So whenever b comes, we will just read that b's, we will just reading that b's, and whenever c comes, we will start pop operation, and by doing pop operation we will compare each c with each a, and we will start popping. And when we will at the d, we have to just read that d's. And remember one thing, we are getting at least one d in the language, means minimum length string also we are getting a b c d only. Okay, so similarly when j is equal to l is there, whenever a comes, okay, a comes, we have to just read that a, and whenever j comes, so whatever number of b's will be occurred in the language, that number of d's we will get because j is equal to l we are considering. So whenever b started occurring, we have to push that b's into the stack. Whenever c started occurring, we have to just read that c's, and finally when we are getting d's, we have to pop each a with respect to, sorry, with each b with respect to this particular d. Okay, for one d we will pop one b. Okay, so we are getting two-way solutions. So just try to design pda for this one, pda for this one, and after that we will combine both pdas into one pda, and that pda becomes non-deterministic pda. So let's start designing that. So I will start with q1 state. So I'm in q1 state, just a second. Okay, q1 state, and initially top of the stack is z0 and input is a. I'm designing for this one, I is equal to k. So a is the symbol that is input, and top of the stack is a. I have to push that particular a into the stack. Similarly when a is occur as an input and top of the stack is also a, I have to push that particular a into the stack. Next, suppose a is ended, I am taking a string like this a, and suddenly I got b, two b's. I have to just read that two b's. But what if I will write that b transition here itself? Okay, b and top of the stack is a, so I have to just read this, means I will keep that top a as it is. Okay, so I have read this b by using this transition, and this b is also by using this transition. But if I will get another a after b, so that a is also accepted by using this transition, and this should not be happen in this particular language, because compulsory, if A is ended, after that A only we will start getting B, and if B is finished, after that we will get C, and after that only we will get D. The sequence should not be disturbed. So I should not write this transition here. For writing this transition, I have to change the state. So I am changing the state and I am writing that operation. So B is the input and top of the stack is A. So I will make as it is only. I will put that stack up top of the stack as it is, and I will move to the next state, that is Q2. Again, in this state, if I will get B as input and top of the stack is A, I will make that A as it is. Now suppose B's are over. Okay, B's are over, and after that I am getting C. So for this C also I am changing the state, because if this C occurred, then again if I will do this C occur and I have done this operation is here, suppose C and top of the stack is A, here epsilon. So next top I am getting A only, because I have pushed 3 A's, and after C if I will get B, then this string is also allowed by using this operation. So that's why for this transition also I am changing the state. So I am changing the state and I am writing here C is the input and top of the stack is A. So for this I have to pop. Okay, so now I am in Q3 state, and in this state I will get same operation for more number of C's. When C is the input and A is the top of the stack, becomes epsilon. Okay, now C's are over, and if I am left with D, I have to again change the state, because if I will accept D here itself, so there will be possibility that A, B, C string should be accepted, because here from here if I will go epsilon Z naught by accepting D here only, so ABC should be accepted here, but J is compulsory greater than or equal to 1, so at least D 1D should be there. So that's why while changing the state I am giving transition for D. So whenever I will get D and top of the stack becomes, now all A's are removed, so top of the stack is Z naught, then I will make that Z naught as it is and I will move to the next stage, that is, just a second, Q4 state. Okay, and here also in Q4 state also there are higher chances that we will get more number of D's. So D on Z0, I will make that Z0 as it is, and finally I am with Q5 as a final state, and finally I am left with epsilon as a input and Z0 is the top of the stack, so I will make that top of the stack as it is and I will move to the final state. Okay, so this way this should be accepted. Similarly, I will start when J is equal to N. Whenever A comes, I have to just read that A. So here I will write transition like this. Whenever A comes and top of the stack is Z0, I will make that Z0 as it is. Just I have to read this. Similarly, when B started occurring, so I have to push that B into the stack. So B started occurring, I have to push that B into the stacks on B Z0. Similarly, we will get transition like B on B. B is the input and top of the stack is B. I have to push that B into the stack. So this will become BB. Now B's are over, and C, if I will get C, I will change the state. You know why? Because already we have seen if we will not changing the state, then we will come across various problems. When C is the input and top of the stack is B, I will put that B as it is and I am changing the state. I am in Q7 state. Now in this state also, if I will get more number of C's, and top of the stack is B, I'm just reading that C's and putting that B as it is. And finally, if I will get D, I have to pop each B with respect to each D. So I'm getting D as the top of the stack and sorry, D as input and B as the top of the stack. I have to pop, that is epsilon, and I'm moving to the next state, that is qweight. Okay, so I'm in qweight state, and here also if I will get more number of D, I have to pop, and top of the stack is B, I have to pop each D, each B with respect to each D. And finally, if I am left with only epsilon, I will go to this state only. I will use this particular state as final state only. So epsilon and top of the stack is z0. I will put that z0 as it is and I will accept that string. Okay, so this is for when j is equal to L, but we want combined DFA, so combined PDA. So I will start with Q0 state. This is the initial state, and whenever I want this solution, I have to push A into the stack. So A on Z0, I have to push that A into the stack, so it will become AZ0. So this will become AZ0, and already this transition is there, so I will remove this transition. Similarly, when I have to follow this way and I have to come across this solution, that is when j is equal to L, then for this whenever A occurs, I have to just read that A. So A on Z0, top of the stack is Z0, I have to keep that Z0 as it is. But here I am not removing this transition, because if I will get more number of A's here, then by using this transition I will read that A's. Okay, so this is the complete NPDA, that is non-deterministic PDA for this particular language. So after solving such type of examples, we have observed things like that. Here the context-free languages are divided into two types, that is deterministic context-free languages and non-deterministic context-free languages. The deterministic context-free languages are accepted by deterministic PDA, and similarly such type of languages which are not deterministic context-free languages, which are non-deterministic in nature, are accepted by non-deterministic PDA. Means we can say that deterministic PDA is less powerful than non-deterministic PDA, because the non-deterministic PDA is accepting more number of languages compared to deterministic PDA. Okay, so similar way we can say that non-deterministic context-free languages are powerful than deterministic context-free languages. I hope आप लोगों को ये सारे clear हुआ होगा. And these are the examples regarding context-free languages and non-deterministic context-free languages. So yeah, here we are ending with PDA also. In next class, we will take some languages and we will identify whether that is regular languages, or we can say that that is a context-free. In context-free also, we have to identify whether that is a deterministic context-free language or non-deterministic context-free language, and this can be identified by using whether these particular languages are accepted by deterministic PDA or non-deterministic PDA. I hope you have understood this lecture. So we will meet in the next lecture. Thank you so much.